Going to review the quadratic formula, imaginary solutions, and the discriminant. Okay, so first thing is we should review what the discriminant is. And the discriminant is b squared minus 4ac. And that's going to tell us how many solutions and what kind of solutions. So the first two problems, we're just going to evaluate the discriminant. I highly recommend that you identify A, B, and C. You don't have to, but you will make less mistakes. A is 1, B is -3, C is 4. So B, -3 squared, don't forget your parentheses, minus 4, A is 1, C is 4. So this becomes 9 minus 16, which is -7. The discriminant is negative. This has two imaginary solutions. Three dots in a triangle formation means therefore. Three dots in a triangle formation means therefore. I think I spelled that wrong. I'm not sure. Okay, next one. Same thing. Let's label A, B, and C. A is 1, B is 5, and C is 10. B squared minus 4ac. B is 5 squared minus 4ac. Looks like this one is also going to be negative. 25 minus 40, which is -15. No real, two imaginary. I'm supposed to say imaginary, my handwriting leaves a bit to be desired. Okay, so 3, 4, 5, and 6 we are asked to solve. I'm going to start with the discriminant for every single one of these problems, maybe. Okay, we should start with the discriminant because it's going to tell us, are they real solutions? Are they imaginary solutions? And it's also going to tell us if the problem is factorable. And I will review that in a minute. Okay, so the discriminant, b, which is 4 squared, minus 4ac, which is -7. So this becomes 16 plus 28, which I think is 44. Okay, so it has two real solutions. The discriminant is positive. So this is two real solutions. 44 is not a perfect square, so this problem is not factorable. Well, I've got half the quadratic formula done. So the quadratic formula, opposite of b, -4, plus or minus the square root of b squared minus 4ac, but you already did that. You just did b squared minus 4ac, and it was 44. So the quadratic formula is halfway done for you. All over 2a. Right at the bottom here, in case you've forgotten the quadratic formula. X equals opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And b squared minus 4ac is the discriminant. So I just found out in number 3 that the discriminant was 44. So I'm halfway done. Okay, so let's simplify. 44 is 4 times 11. 44 is 4 times 11. Square root of 4 is 2. So the 2 comes out. The 11 stays in. Now I can reduce the constants. -4, 2, and 2 all divide by 2. So my answer is -2 plus or minus 2 divided by 2 is 1. I don't need it. And in the denominator, 2 divided by 2 is 1. I don't need it. So my answer is -2 plus or minus root 11. Okay, if you remember, I know it's been a long time, but if you remember, we had done a worksheet and we tried to decide choosing the best method. Should I use the quadratic formula? Should I factor? Should I complete the square? Or should I use the square root method? And here, b is 0. b is 0, you should use the square root method. Okay, great. Do you have to use the square root method? No. Can you use the quadratic formula? Sure, but it's going to take you much longer. So I'm just going to rewrite the problem. For the square root method, I'm going to subtract 72 from both sides. Okay. This is going to be imaginary because the 72 is negative. So I'm going to square root both sides. As soon as you see the negative, right away it becomes an I. So it's going to become plus or minus because I'm solving. And then it's going to become I root positive 72. Now, of course, you can skip that step, but I just want to refresh your memory that as soon as it's negative, bam, I. 72 is 36 times 2. You can use 9 times 8, but you're going to have to do it twice then. So use the highest perfect square. Square root of 36 is 6, so that comes in. It goes after the plus or minus sign, after the plus or minus, because we're multiplying root 2. There you go. Okay, the last two, they're not equal to 0, so you have to set it equal to 0 first. So I'm going to add 3x to both sides. And there are no like terms. There are no like terms. This becomes 2x squared plus 3x minus 9 equals 0. b is 3, so you cannot use the square root method. b is not 0, no square root method. So I'm going to use the discriminant. Maybe I'll get lucky and I can factor it. You may not like factoring, but it is definitely a skill you need to become very good at. Okay, discriminant, b, 3 squared minus 4, a is 2, c is negative 9. This becomes 9 plus negative 4 times 2 times negative 9 is positive. I believe this is 72. And 9 plus 72, I believe, is 81. And 81 is a perfect square. 81 is a perfect square. So I'm actually going to factor this. I think it's good to review. So I'm just going to rewrite the problem. When it's equal to 0, so we're going to factor this because 81 is a perfect square. So this is factorable. Okay, so if you need to make your diamond, at the top would be negative 18, and at the bottom would be 3. If you can guess and check, more power to you. I believe this is positive 6 and negative 3. No shortcut. A is not 1. If A was 1, I could just do my parentheses, bam, bam, and be done. So either do the box or group it. I'll just do the box really quick. Again, if you can guess and check, more power to you. First box, first term. Last box, last term. First term is 2x squared. Last term is negative 9. Once you find the quote unquote what works, once you get the 6 and the -3, the -18 and the 3 have no bearing in the problem. 6x, -3x. This is going to be 2x. You may need to slow the video down for yourself. This factors as 2x minus 3, x minus 3. You'll get the same answers if you use the quadratic formula. You will get the same answers if you use the quadratic formula. So on quiz, test, final exam, whatever, is it okay if we just use the quadratic formula, Ms. Babiak? And the answer to that is make sure you read the directions. If I tell you to solve by factoring, you must solve by factoring. And in your future math classes, factoring is going to become critical. The quadratic formula takes a long time depending on how good you are at it. So x is 3/2 and 3. Again, same answer if you would have used the quadratic formula. Okay, the last one. So just like problem number 5, it's not equal to 0. So I'm going to subtract 3x squared from both sides. And I'm going to add 2x to both sides. And some of these are like terms and some of them are not. 4x squared minus 3x squared is x squared. Plus 2x plus 1. This one's going to be factorable as well. I think this is a perfect square trinomial. No square root method because b is not 0. A is 1, b is 2, c is 1. So b squared, which is 2 squared minus 4ac. This is 4 minus 4, which is 0. And you don't think of 0 as being a perfect square, but I can factor this. But this is special. This means there is one real solution. The discriminant is 0, one real solution. Okay, I'll do both. I'm gonna factor it and use the quadratic formula. So first thing I'm gonna do is I'll factor it. So I'm just gonna rewrite it. X squared plus 2x plus 1. I'm gonna factor this. AC is 1, B is 2. That's 1 and 1. What multiplies to 1 and adds to 2? 1 and 1. A is 1, so I can shortcut it. So this is x plus 1, x plus 1 equals 0. A is 1, 1x squared. So then I can just go straight to the parentheses. So here the answer is x equals -1 and x equals -1. I get that answer twice, but it's one answer that occurs twice. This means the vertex is on the x-axis. So here is my one real solution by factoring. Okay, so here I did factoring. Do the problem again, and this time I will do it by quadratic formula. So the quadratic formula, I already did the discriminant, it's 0. I already did the discriminant, it's 0. So this is going to be the opposite of b. B is 2. Plus or minus the square root of b squared minus 4ac, which we already figured out was 0, all over 2a. Square root of 0 is 0. So this becomes -2 plus or minus 0 over 2. Square root of 0 is 0. How did I get 0? I did the discriminant to start with. Well, -2 plus 0 is -2. -2 minus 0 is -2. So either way, you get -1. Same answer, either way. Same answer, either way. Oh, I should have x equals. I forgot that. Okay, something I should have done at the beginning of the video. That is review the solutions for the discriminant. If the discriminant is greater than 0, 2 real. If it is equal to 0, that's 1 real. And if it is less than 0, 2 imaginary. That is a review of the discriminant, imaginary numbers, and the quadratic formula.